All right, this is section 8-1, solving equations with variables on each side. Let's start with example number 1. Example 1 says to solve 2x plus 3 equals 3x. All right, first thing, and we have learned this in a previous chapter, but we need to draw our division line there, with dividing the two sides up. And then the way I've taught this before is we label these terms. All right, we've got variable term, which is 2x. We've got a constant term, which is plus 3. And we have another variable term, which is 3x. Variable terms are obviously the ones with variables. So we're trying to get these on opposite sides. So we got to combine like terms, but what we need is the c's on one side and the v's on the other, or we need the v's on one side and the c's on the other. So I think the only way to do this would be to take this variable term to that side. Well, the way we do this right now when we're combining like terms is we add or subtract. So what I'm going to do is I'm going to subtract 2x because that's a positive. If you have two x's and you subtract two x's, you have 0 x's left. But really, you don't have to have that because they equal 0. And when they equal 0, that's basically not there. So you have 0 plus 3, which 0 plus 3 is 3. Equal sign comes down. And then on this side, this is not a division, right? That's 3x minus 2x, which is 1x. And in this case, 1x is the same as x. So 3 equals x. Leave that as your final answer. And you can always plug this back in to see if it works. If 3 is x, 2 times 3 is 6. So you get 6 there, plus 3 is 9. So this side equaled 9. And then on this side, 3 times, well, x is 3. We just learned that 3 times 3 is 9. Since 9 equals 9, we know that this was a correct answer. So that's example 1. Let's go to 2. Example 2a, actually. Example 2a says 5x plus 4 equals 3x minus 2. Draw your line. Label variable, constant, variable, constant. Now on this one, we've actually got 4 different ways we could solve this. We could either take this v to that side, which if we took that v to there, then we'd have to take this c to there. So that's 2 different ways you could start it. Or we would take this v to that side, which would mean we'd have to take that c to that side. So one way or the other, you've got to get all the v's on the left and c's on the right, or vice versa. To be honest with you, there's no real great way to start this, so you just pick one of these 4 terms and add or subtract the opposite value of it. I'm going to start by subtracting 3x, and the reason I'm doing that is because I think 5 minus 3, which is 2, is a nice and easy number. So 5x minus 3x is 2x, drop the plus 4, 3x minus 2x is 0x, which is 0, so that is gone. And then over here, this is a negative 2 that drops down, so it equals negative 2. Now if you notice, we took the v's to the left side, so that means we need the c's on the right side. So the plus 4 we need to get rid of, so we subtract 4. And this is where it gets tricky again. You have to be careful. Keep extending our line here. That's negative 2 minus 4. So if you go down 2 and down 4, you've went down 6. Alright, so now here we are at the last step, and since they're timesing, x and 2 are timesing, now we're trying to get x by itself. Opposite of that is divide by 2. So the 2's cancel out, x drops down, negative 6 divided by 2 is negative 3. And that's your final answer. And once again, you can plug that back in. 5 times negative 3 plus 4 would be negative 11. Over here, it would be 3 times negative 3, which is negative 9, minus 2, which is also negative 11. So that did work. I checked both sides, and got negative 11. So that was correct. Let's go to example 2b. Example 2b says 2.4 plus a equals 2.5a minus 4.5. Draw your line. Constant, this is a 1a, that's a variable. 2.5a is a variable. Negative 4.5 is a constant. So like I said before, I like to subtract these in a way that gives me a positive variable. So I know I have a 1a on this side. If I subtract 1a, that'll give me a positive variable. So 2.5 minus 1 would be 1.5a. Drop everything else down. Now since I took my variables to that side, I take my constants over here. And by the way, remember this is, the way I started this one is just one of 4 different ways. I could have subtracted 2.4 as my first step. Or I could have subtracted 2.5a as my first step. Or I could have added 4.5 as my first step. So one of those 4 is fine, but after you do that, then it changes how the rest of the problem gets done, and what you guys see on your problems might be different than another student, depending on how you all start these. But what we did is we took the variables to the right, so that means I got to take this constant to the left side. So I got to add 4.5, and notice that comes out kind of nice. You get 1.5a equals, and this is 6.9. And your last step is getting a all by itself. Since they're timesing, you need to divide. So 6.9 divided by 1.5. Again, that's a problem that we should probably do over on the side. So I'm going to do bottom into top, 1.5 into 6.9. Move it over, move it over. So this is 15 into 69. 15 doesn't go into 6. 15 times 4 is 60. Subtract is 9. Drop a 0. Your decimal's right there. And 15 goes into 90 6 times exactly. So there you go. That wasn't too bad. So again, we're back over here. 6.9 divided by 1.5 is 4.6. Drop your line down. It equals a. And I know that would be a harder one to check. So if you do have a calculator, that wouldn't be a bad idea. Take 2.4 plus 4.6 and see if that equals 2.5 times 4.6 minus 4.5. See if both sides are equal. So that's the answer for 2B. Let's keep going to 3. Here's example 3. It says under Plan A, an annual membership costs $30 plus $1.50 for each dollar rental. So it's $30 plus $1.50 per rental. Under Plan B, the annual membership costs $12 plus $3 per rental. Notice the word per, or for each, is actually timesing. What number of DVD rentals results in the same yearly cost? Well, in order to figure that out, we are setting these two equal to each other. I'm going to put that as 1.5R and equals 12 plus 3R. So as you can see, you had to write your own little expression there, algebraic expressions. This was Plan A and Plan B. And then to figure out, so many rentals will make both of these plans end up costing the same amount. And then at some point, one plan will cost more than the other depending on the number of rentals that you get. If you don't plan to rent very much, looks like Plan B might be the one to do. But if you plan to rent a lot, Plan A might be the one. So we're going to figure out how many it takes so that they're exactly equal. Well, same thing here, constant, variable, constant, variable. I'm going to start by subtracting 1.5R on both sides. That gives me 1.5R here. That's positive. plus 12 because it was positive 1.5, and then on this side drops the 30. Now since I put my variables on the right, I got to take my constants to the left. So that gives me 30 minus 12 is 18 equals 1.5 R. Going to give myself some more room here. So on this case now, I'm trying to get R by itself. I got to divide by 1.5. Let's go ahead and do that. Bottom into top. That decimal needs moved over, so that also needs moved over. So this is really 15 into 180. 15 doesn't go into 1, it goes into 18 once. Subtract, you get 3, drop a 0, and 15 goes into 30 2 times. You get exactly 30 and nothing left. So back over here, 18 divided by 1.5 is 12, and that equals R. So R was standing for the number of rentals, so it'd be 12 rentals. You would end up spending the same amount. So if you rented more than 12 times in a year, you'd probably want to get Plan A for greater than 12. If you don't rent very much, then Plan B would be for less than 12 rentals, as far as the number, what it would cost you. 12 exactly would give you the same amount no matter which membership you chose. So that's all the problems. This is solving equations with variables on each side. Good luck.